let's talk a little bit about introduction stuff. Actually, first of all, let me ask you guys, because now we have several of you that created your GitLab account, right? And you have sent me this stuff and you have done assignment 0, right? No? No.
Not assignment 0.
The online students are much better, sorry. No. A bunch of students have done it, and I thought some of them would be in this class. Sorry? Whether you have created your GitLab account and put it there and tried assignment 0. Yes. Try it. And if you have questions and stuff, ask, right? That seems to be reasonably okay. But several people have done it, so hopefully it's not that bad.
So if we go to our GitLab account, it's already there?
GitLab, yes.
The assignment is already there?
Yes, all of the assignments are already there.
In the GitLab?
Yes, but actually I'm giving you here instructions of exactly what to do, what to type. And I had repo set up for how to set up the repo, right? Oops, not the video. I want you guys to go through this. I don't grade assignment 0, but if you don't do assignment 0, then you won't be able to do assignment 1. And it won't be because you don't know how to program, it would be because you're still fighting with installing the JDK in your machine and things like that. So this will get you out of that mode, right? Hopefully after doing assignment 0, that basically that kind of verifies that you have Git, you have created your account, you have a compiler, you have an IDE.
There was also like a assignment 0 that was introductions, correct?
What do you mean?
Or am I?
On D2L?
Yeah. So
It's the same thing.
Oh, okay.
I just put the links all over
okay,
so that you can find them.
Okay.
So what is SSH key?
What's what?
SSH key. SSH key.
SSHK?
Key.
Key. Oh. You need a way to authenticate yourself to the server, right? A common old kind of technology is called SSH for secure shell. And it uses a really long key that you generate and is stored on your machine so that it verifies that it is you on that machine. And so GitHub allows you to do that if you want. It's probably a very good idea for you guys to figure out SSH and figure out how to add keys because this will serve you throughout your career. On the other hand, it's not a requirement for this class, which means, yes, you probably want to learn about that stuff. You don't want to learn it tonight. You don't have to learn it tonight. You learn it after you do assignment 0. And actually, GitLab has stuff on that. Like, if you go profile settings, has SSH keys, and it should have some instructions. It tells you some instructions on how to do it and why you're doing it and things like that.
Yeah.
But you don't have to. If you do, what that means is that you don't have to be typing your password anymore. If you do the stuff with HTTPS, you don't have to do it either. Come on in. But the repo has your password, which is slightly bad. It's not a big deal. It's kind of an extra fancy stuff that you don't have to do. But you do have to do assignment 0 and the setup and get all of that stuff on your machine. Get like JDK, Eclipse, IntelliJ, Git client, create your account, and actually if you can also post it there. I think I have answered to everybody who emailed me, but that may not be true. Like I have created the repos for everybody who emails me. No? When you have a chance, post it on D2L, on the D2L discussion. You did?
Yeah, I did as well.
My username is like my
Wait.
email. Is it possible?
Wait a minute. Yeah. Wait a minute. That is not true. Oh, that is true. 2 people just posted. Yeah. But that's, who are you? Dilafruz or?
Yes.
And then who are you?
Jasmine.
Jasmine.
At the Arkham.
Harvard.
Yes.
I've created your repo. It's already there.
Okay. I'll go back and double check.
Yes. It should appear on GitLab.
Okay.
And you actually probably get emails from GitHub when you do it. No? From GitLab, sorry. No, you don't get emails from GitLab. Actually, yours I probably haven't created. Because I just saw these 2. So, Dinomova and Emfar had one, I haven't done it. Sure. Okay, so besides setting up your computer, which is very important because that will enable you to learn, let's talk a little bit about Java. And we did this stuff. We were doing this, right? And we were using Java REPL. We talked about how you can create variables, right? Int a, semicolon. In Java, almost all your statements end with a semicolon. In Java REPL, they don't have to. So this is almost Java, but not quite. And then we can assign variables, assign values to our variables. We can read our variables. We can combine them in expressions, right? They follow the standard rule of math. We do have integer division. So if a is 3, how much is a divided by 2? 1, right? You have to go back to elementary school. And how much is a percent? 3. 0, right? Divide 3 by 3, you get 1 and remainder of 0. So you can assign, you can declare and assign. Your variable names can be almost whatever you want. You have letters, numbers, $sign, and underscore. And you cannot start with a digit because Java will get confused and thought you were trying to do a number. We talked a little bit about the shorthand operators. You can combine almost every operator with equal. So if you were going to do something like this, a equals a plus 5, you can do a plus equals 5. So this does 2 things. It increments a, and then it yields the value of the new value of a. Does that make sense? So now a is going to be 8. Does that make sense? Very cool. There's slightly weirder operators, which is plus plus. A plus plus will increment a, is equivalent to a equals a plus 1. But if you do it like this, it would return the old value of a, so it would yield 8, not 9, even though a is 9. If I do plus plus a, then it would do the new value of a after incrementing, which would be what?
It will give the old value if you do A++.
Yes, it still increments it. It changes the value, but the value that it returns or that it yields is the old value.
Okay.
This one will yield the new value. In this case, how much is A right now before doing this stuff?
Now it will say 10.
9. So if I do plus plus A,
10.
10. And that's what it returns. For the most part, your code shouldn't use this thing. So your code shouldn't really use assignment as an operator that yields a value, because that tends to be confusing. But if you do, you need to know these things. I tend to always write plus plus A or minus minus A. Minus minus is subtracting 1. Does that make some sense? Just so you know, although it's probably not terribly important in this class, ints in Java are not infinite, right? They have a maximum value and a minimum value. I think ints in Java are 32 bits. Primitive data types. Here are all the other guys. Byte, short. Int is 32-bit, right? So what does that mean? I can have from minus 2 to the 31 to 2 to the 32, right? Which is something like from minus 2.5 billion to 2 billion. Or 2.5 billion. If you want bigger, then you use long, which gives you 64 bits, which is a lot. For the most part, we'll be dealing with small numbers, so ints are good enough. Now, the other thing, and it's not necessary for this class, but you probably want to have a clue about how integers work, right? This is the same as math, except that computers don't use digits, right? They don't use numbers from 0 to 10. They use binary. So they use numbers from 0 to 1, right? Digits, we are base 10, so we use 0 through 9. Computers are base 2, so they use 0 and 1 only, right? So how do I count in binary? 0 is 0. 1 is 1. 2 is what? 1 and 0. Just like I do in decimals, right? When I get past 9, I need 10, right? So 3 is 1, 1. 4 would be 1, 0, 0, right? Does that make sense? Eventually, I can have this number. That's my maximum integer. It's 31 ones. Maybe, yeah. Does that make sense? You don't terribly care, but they represent negative numbers by using 2's complement. My mental model, although it is not true, is that you put a 0 for positives and a 1 for negatives. But that's not exactly how it works. It is equivalent, but slightly different. You don't need to know that stuff. All you need to know is kind of, it's the same as decimals, but in binary, right? Probably in computer architecture, you will get a little bit more deeper into binary.
The maximum ones would be 33 or
31, because we have 32 spaces, but one of them is for design. One of them is for representing positive or negative. So you have 31. And it's not quite the same because you'd have two zeros. You'd have plus 0 and minus 0. So they use the minus 0 for something else. They use 2's complemented. So you actually have one more negative number. So you can go from minus 2 to 31 minus 1 to 2 to 31. Or at least that's what this guy said. Yes. Oh, actually, no, the other way around. From minus 2 to 31 to 2 to 31 minus 1. So actually, all ones would probably be a negative number. Okay, I'll believe them. And that is something like 2 billion, 2.5 billion. We can actually test it by doing this stuff. You can start with 1, right? We multiply by 2. We get 2, right? We multiply by 2 again. We get 4. 8, 16, 32, 64, 128, 256, 512, 1024. By the way, this one is important for you to know. Actually, this one is important because it's 1 byte. 2 to the 8 is 256, which is 1 byte. This one is important. 2 to the 10 is 1024. That gives you an idea of 10 bits is about 1,000. It's about 3 digits. So you know that 2 to 31 is 1,000 million, billion in English. So 1,000 millions. But we can keep going. 4096, 8192, 16,000 and peanuts, 32 peanuts, 65,000 peanuts. That's 16 bits. When we used to have short things. We keep going, and eventually what is going to happen is that we are going to break Java. Maybe here. No. Good. I think that's billions, right? 268 million. So we still have 4 more, right? Two more duplications. Maybe 3 more duplications, sorry. 500 million. It's 1 billion. And then, boom, we broke it. Now we get a negative number. It wraps around. Does that make sense? And if we do this minus 1, we break it again. Because it wraps around both for positives and negatives. Does that make sense? Do you remember playing old video games, right? Eventually, after 12 hours of no sleep, you wrap around the counter, right? Like Space Invaders or Asteroids or something like that. You guys are too young. You never played those things. Okay, never mind. Old video games used to have this. And was a badge of honor where you could get the counter to reset. Your car, right? If you drive an old car, eventually the odometer goes back, right? Old cars. They don't do that anymore. It's all digital. But hey, old cars had that. You've seen movies. It is the same effect but it happens in binary. Does that idea make sense? The details are not terribly important, right? What do you do when you need to figure out the exact details? Either you come to an interpreter, right, or to a compiler and compile it and print and see what happens, or you Google it or Bing it. Does that idea make sense? But you need to know, right, you need to understand the principle of how it works, and then it doesn't terribly matter. So we have ints. Ints are very useful, but they are not the whole thing. We also have floating point numbers. Floating point numbers are uber cool. What's the circumference of Earth? Oh, God. It's 4,000 kilometers, I think. Because that's how they used to define the meter. Earth circumference in meters. It's 4 million meters. That 40,000, sorry. I was off by 1 order of magnitude. That's how they used to define the meter before they. Is that an accurate statement? What do you think happens? No, depends on where the heck I measure, right? If I'm measuring over the average, it's a little bit more, right? On the other hand, is it accurate enough? Probably, right? Depends on what you're trying to do, right? That's how floating point numbers work, right? If I'm doing something that's 40,000 kilometers, right? 40 million meters, is that 75 important? Right? Probably not. I probably don't terribly care whether it's 40,000 or 40,075, right? If I'm trying to figure out how long is it going to take me to drive home, do I care about 75 kilometers? Probably yes, because my home is probably closer than 75 kilometers, right? For those of you who think in miles, a mile is a little bit more than 1.5 kilometers, so that's about 50 miles, 45 miles or so, right? So of course I care, right? Because my home is only 15 or 20 miles from here, right? If I'm trying to measure the distance to my home, Google says something like 15 miles. That's good enough. Do I care whether it's 15 miles or 15 miles and 5 feet? I don't give a hoot, right? That's how floating point numbers work. They use the equivalent in binary of scientific notation. Do you remember, probably somewhere in high school, they talked about scientific notation? Just count the number of zeros, right? Say it's a 1.5 plus 7 zeros, right? Or something like that. Floating points does the same in binary. You have a number of digits that you can keep track of, and then a number of zeros, right? So that allows you to represent numbers with a very, very wide range, right? Because you have, let's go figure out, let's go read the actual stuff. A float is a, they don't tell you, they are horrible. The maximum is 127? Nah, God. So use K, which is 8. So it can represent up to 200, it uses 24 bits for the decimal part, and then 8 bits for the exponent. So it can have up to 256 zeros. They're not zeros, they're actually twos, right? Does that make sense? It gives you a much wider range at the cost of losing precision, right? So what would happen with a floating point number if I'm doing these things? I can use float, and float has less precision, double has bigger precision. Float b equals 1. 1 tends to work, and it will be printed the same way, but I can do 1.00000000001. That would probably work. Oh, it didn't do it. Oh, because it's a double. Never mind. Oh, I can do this. Convert it to a float. Oh, and here's the deal, right? I don't have enough. This works, right? This doesn't work anymore. It's too close to 1. So it just says, meh, 1's good enough. Does that make sense? If you're talking about 1, this is 3, 6, 9, 10, right? 10 decimal spaces. So it doesn't terribly matter. The difference between 1 and a 1 with 9 zeros and a 1 is nothing. Does that idea make sense? It is the same stuff that you did in high school as scientific notation. Computers do it as floating point values. They have a specific size. So a float will have 32 bits total, and a double has more stuff. So actually, if instead of declaring it as a float, I make it a double, it would work. It has enough precision to distinguish between 1 and this other guy. Eventually, if I put enough zeros, it will not have it, right?
Double is also a kind of float. Or
A double is a kind of float, yes. In fact, what I do, numerical precision is actually quite complicated, depending on what you are doing. You may lose more or less numerical precision. It is kind of, there's a branch of mathematics for number theory and that kind of stuff that you could study, definitely a semester class on numerical methods, where you see how to do those things with programming and things like that. We don't do that in this class, so what I do is I will always use doubles. That's the cheating way. The most precision I can get, right? We will later on see there's actually big decimal, which represents the numbers almost like a string, and so it has arbitrary precision at the cost of performing a lot worse, being obscenely slower than floats and doubles. Chances are that your computer has specific hardware for doing stuff with floats and doubles. So these things are fast as hell. Almost as fast as ints. Again, the details are not terribly interesting, right? How many zeros can you have before it loses precision? Doesn't terribly matter. Just know that eventually it breaks. Does that idea make sense? Yes. Floating point values have normal arithmetic. And they don't have percent. Just returns whatever the heck it feels like. Doesn't make sense to do percent, right? Actually, it appeared to do it. Well, they do, sorta, kinda. It's not very meaningful, but they do have the operator. Does that idea make sense? So you understand variables, ints, and floats. Yes? What do you do to understand them better? When you get home, go to Java REPL and start typing stuff, right? This is a contact port. You need practice. You need to do a million of these, right? Until it feels natural and obvious. And you need to go figure out again, when does it break? What happens if I use a short instead of an int? When does it break? All of that. Does that make sense? So go play, right? And then after that, just search for the actual values. Don't memorize this stuff. You don't really need to memorize how many bits are there in an int versus a float or something, right? You probably memorize a couple of the important ones. You probably memorize that an int is 32 bits in Java, but but not the other guys, right? So we are done with that stuff. Any questions on variables, ints, or floats? No? Life is good? Cool. Now, let's talk about Booleans. We are going to be describing algorithms for our computers. We're going to be telling our computers, do this, then do that, right? We have this sequencing that changes the value of our variables, but we also are going to have conditions and things that if this happens, then do this. If not, do this other thing, right? And so we need better language for talking about truth, right? So we have these Boolean variables. Somebody came up with the idea and said, wait, true and false are just like numbers, right? So they're just like numbers. It's just a data type, except that instead of having from 0 to 31 values, you have two values, 0 and 1, right? Or true or false. You can call them whatever. And we have kind of the same kind of operators, right? What are our operators for Boolean variables? How do we operate on truth? How do you combine things that you
Well, equal to greater than less than.
Okay, comparison operators, right? Convert other stuff into true or false, right? I'm older than 4, right? It's false. I wish. It's false for high values of 40. So they allow us to convert. Now, if I have two values, one of them is true and one of them is false, what kinds of things do I do to combine? What kinds of things do I do in English? If I have variables like I have 2 kids and I'm older than 40, what can I do to combine those two variables, those two values, those two things? I say and or, right? Those are the things that I have in English, right? So Boolean variables and Boolean operators, right? For Booleans, I only have true and false as my values, and they are lowercase. My data type is Boolean, and then I have not, and I use 2 ampersands. And yes, in your test, since you're going to be writing, you can write whatever looks something like this. Very few people can actually write an ampersand without a computer. It's a really weird thing. And or, which is 2 vertical bars. On your keyboard, they probably have holes. They used to. My Mac keyboard doesn't have holes on the vertical bar. The character used to have holes in the middle. But there is one important thing about or. In English and in most natural languages, or is supposed to be exclusive, but it's not really exclusive, right? It would sound weird if I say, I am a man or both, because I'm both, right? So it would just sound weird. Does that make sense? What happens if 2 things are true and you combine them with an or? What happens in English? There's a strong presumption that only one of those is true, right? In computers, it's perfectly okay and you still get true. In English, it's a presumption, but it's not required. What happens if you ask a kid, what do you want, cake or ice cream? Well, the obvious answer is both, right? I mean, cake. Why the heck are you asking? Right? That's how it works. So there's a presumption that it's one or the other, right? Either exclusive or, but in reality, you can always answer both, right? And so computers always do both. So if you have true and false, the end result would be what? True and false.
True and false.
False.
false. If you have true or false, the result is true. If you have true or true, the result is true. Right? So you just use these things as operators. So I can do I can do stuff like B and B2. Does that make sense? I can also do, what does this do? B double ampersand equal B2. This is the equivalent of B equals B and B2, right? So the result would be false, but we also make, oops. Oh, I cannot do it. I lied to you. Never mind. Okay, you can't do it with logical operators. I lied. Don't believe everything you hear from me. We also have comparison operators, right? Int a equals 10, a greater than 10 yields a boolean, right? And yields false because a is not greater than 10. A greater than or equal to 10 yields true. I have equal for comparing and seeing whether two things are equal. Why? Because they use equal for assignment, right? And so if I need to compare, I need two equals. Just to have a different operator. Not equal for different. And I can combine these with the Boolean operators. Does this make sense? Any questions on this? Makes reasonable sense? Go play.
Yeah, that's what.
Right?
We understand now, but we can forget.
Go play. You need to go play till your fingers learn this stuff, until this stuff becomes obvious, kind of like it is how it happens in something like elementary school, right? They make you do 500 additions. Actually, they make you do 500 additions a week for 2 years, right? Which is how you learn to add, and then adding is simple, right? You need to come and do these things over and over until it becomes simple and obvious. Given that you're adults, I don't give you a million exercises. I just tell you to do it and I expect that you would go and do it, and you would monitor when you need more and when you don't. Does that make sense? I'm treating you like adults. If that is wrong, oh well. So go play. Do it again. It's a lot better to play several days in a row, right? So go play tonight, and then go play tomorrow, and then go play the next day, right? Until it becomes kind of obvious. We have the comparison operators, the relational operators. One slightly important thing, although not right now, is that they do short circuiting. If you're comparing two things with an and, right, and you know that the first thing is false, do you need to go look at the second thing? No, because the answer is false, right? So Java will not even evaluate the second thing, right? as we will see later on, we'll be able to define things, and so that second thing may be something that breaks your code, right? That does something horribly wrong and destroys your program. But you know that it's never going to happen if the first thing is false. The same thing with or, if the first thing is true, the second thing is never evaluated. Probably a bad idea to use these, but it's a good idea for you to know it exists. Isn't this cool? Now, let's talk about one weird thing. Booleans, ints, floats, doubles are all primitives. They are considered kind of super special, and chances are that your computer has specific hardware for dealing with them, right? You don't terribly care, but when you add two integers, your computer has an assembler instruction for adding those two integers, and that's what the Java compiler generates, right? The hardware does it is super fast. We will see Java allows us to define our own types, right? And that's what we're going to spend half the class doing, for representing whatever we want. Strings are defined by Java, but they are not primitives. They are defined with code. But they are special. They are special in two ways. One is they are immutable. You can never change them. You can change variables, but not the actual value. The second one is Java actually has special notation for it. So although it's not quite a primitive data type, they are all over. You have a special notation. A string represents a bunch of letters, one after the other. Does that make sense? A sequence of letters. And when we say letters, we mean characters. We mean other stuff that are kind of like letters. So the digit 3 is not a letter officially, but it is, right? Or a period or a semicolon are not letters, but they are characters. The official term is character, the colloquial term is letter. Right? Is a period a letter? No, but I use it in sentences. Right? That is what strings contain. In Java, the data type is called string with a capital S. So I can declare my variable, string S, or initialize. And I use double quotes, the double quote character, to say here starts a string constant and here ends a string constant. Does this make sense? I have S and it is hello. It is almost like ints, right? Except that I use the double quotes to denote here starts a constant. What are strings composed of? They are composed of characters, so I can do char c equals a. And for character constants, I use one quote instead of two quotes. It's not two quotes. I use the single quote character instead of the double quote character. Does that make sense? We'll not use characters too much. What is a character and how many characters do I have? That is actually a very important and complicated and interesting question. How many characters do I have? How many letters can I use? 26. In which language? English, right? What happens if I use a different language? How many characters do I have in Chinese? An obscene number. I don't know if anybody hears Chinese and knows the number or has a clue about the number. It's an obscene number, right? I think Chinese is the only, or not Chinese is the only language. A bunch of languages related to Chinese, like Japanese, and are the only languages that use that stuff. I think Arabic and all those guys, Hebrew, also have relatively few letters, but I don't know. I speak English and Spanish. I speak bad English and Spanish only. So I don't know about any other languages. Do you know of any other languages that have many more letters?
Yes, in our language it's 36.
Which language?
Urdu.
Urdu. Okay.
Tamil and all those stuff also.
But
South
it's
Indian language.
similar to Urdu or something like that, right? Just a few more than English? Or is that correct?
Arabic is between 26 and 36.
Arabic is also the same way?
Between 26 and 36.
Okay. So only Chinese and languages related to Chinese, like Japanese and Korean. And I have no clue about all the other guys who are close but not, like Malaysia and Vietnam and those things. I don't know. My geography sucks. I do computers. So, how many letters do we have? Well, it depends on which language, right? So, originally, all the computer stuff that we use was made here in the US, right? So what did they say? We have 26. Okay, we'll be nice. We'll have different ones for upper and lowercase, right? And we need some for periods and things like that, right? So we'll use 128, right? That's more than enough. That's 26 times 2, 72. Periods, semicolons, new lines, spaces, right? 128. More than enough, right? Then the Europeans said, wait. I need Enye and A with an accent and the other accent and things like that. So they sort of agreed on 256, which includes all of those guys, right? That's 1 byte, so that's perfectly fine for computers. And then we came to Chinese, right? Given that they're only 30% of the world population or something like that, we decided that we actually do care about those languages, right? And so we came up with Unicode. Unicode allows you to do all sorts of things to represent all sorts of languages, right? Including Chinese and Arabic and all of those, because they actually are not quite the same letters, right? So if you combine all of the languages, we have a ton of letters if you combine all the languages. So Unicode allows you to represent all sorts of things at the cost of using more bytes, per character, right? Rather than using 1 byte, you can use 2 or 3 or 4, and there's different ways of encoding and all complicated stuff. That is actually a very interesting thing because it mixes computers and culture and all of that stuff. And as with everything that has to do with humans, we just eliminate it. We'll just assume that you only have English letters for purposes of this class. If you are interested, go look at Unicode. It's actually a really cool thing. It's just not very, we are not going to spend a lot of time on it. Does that make sense? But we do have characters, strings, and the ability of representing weird characters with slashes. So if I want to represent a tab, I use /t. So it's actually printed with extra spacing here for a tab character, right? And I can do /n for a new line, and all those things for weird special characters. We'll probably use /n a lot and /t a little. And this is also how you do other Unicode stuff. And I got S. /123 actually happens to be the S character. You need to go figure out Unicode and which characters and how many characters. And then it becomes, what does your computer support? Do you have a font for Chinese characters and all those kinds of things? for purposes of this class, know that /n and /t exist and are useful. Know that the other stuff exists, and if you ever need it, you'll go Google for it, right? Does that idea make sense? Yes? And it works the same for one character or a string. How do I represent a string constant? What do I put around my letters? Double quotes, right? How do I represent a character constant? Single quotes, right? Their strings are actually objects, which means that I can do things to them. We will see that in Java, I can get any object and ask it with the period, call methods on it, ask it stuff. So I can do abc.length, and that will give me the length of the string. I can do abc.to uppercase. That gives me substring. I give it the first character and the one past the last character. And in computers, how do we count? 0, 1, 2, 3. They lied to you in elementary school. That's why our first module is module 0. That's how you count. Go bug your elementary school teachers. They lied to you. Now, in computers, we normally start at 0 because it made sense. So the first character of the string is the character number 0. So substring 02 would return what? AB, right? 5 would probably crash. Yeah! Eventually it crashes, right? And gets some sort of exception, some sort of error, horrible things. You try to do things that were not allowed. I can do this. What would this return? The empty string. It's not quite 0, right? 0 is the 0 for ints. This is like 0, but for strings. Does that make sense? How do I compare strings for equality? I need to use dot equals. We'll see every object in Java has a dot equals method that compares for equality. Sometimes equal works, but it's not guaranteed to work. When we talk about objects, remind me and we'll explain why equal sometimes works. Equal compares whether two objects are the same as opposed to whether they have the same value. For primitives, it doesn't matter because the number 3 is the number 3. But for strings, you could have two different strings with the same value, with the same letters, but they are different. And so equal would return false, but dot equals would return true. We will talk about it when it becomes important. So we talked about strings, we talked about characters, we talked about escaping characters with a tab, with a slash. So /t is tab, slash quotation if you actually need to put quotes inside your string, right? Because the quote character would end the string constant. /n for new line, and // for actually a slash. Some of the methods, we have length, we have equals. Compare to is similar to equals, but it returns -1, 0, or 1. So if I have abc.compare to abc. Oh, it actually it's actually greater than 0, less than 0, higher than -1, 0, or 1. So it returns number greater than 0, meaning this guy is bigger. Because the ASCII code for the letter A is 97, and the ASCII code for the capital A is 65. And so the string lowercase abc is bigger than the string uppercase abc, because lowercase a comes after uppercase a. And that's their first character. I could actually do compare to ignore case, and that would return 0 because they are equal, if I don't care about capitalization. Does that make sense? And again, keep in mind that capitalization only works for English. If you have an A with an accent, when you capitalize it, you may not get capital A. If you do French or Spanish or things that have accents and umlauts and weird stuff on top of your characters. Does that make sense? So we have talked about the length method, dot equals dot compare to and dot compare to ignored case. Concat, which allows you to concatenate those two strings. So I can do abc dot concat def, and that would return abcdef, right? If I don't want to do that, I can use plus. So is the plus operator for strings or the concat method? To concatenate, to add two strings. Concatenate is a fancy method for put them together. Substring returns a string, and char@, returns one character. Is this the same as what do you think would happen with this? Are they the same? What would the first thing return? What would this yield? The character A. What would this yield? A string containing one character, A. Are they the same? They cannot even be compared. I get a, you try to compare, right? One is in kilometers and the other one is in kilograms. They are different types. They're completely different things. So you cannot even compare them. One is one letter, right? Always one letter. The other one is a bunch of letters that happens to be only one. Does that make sense? No.
One is an object and other is
One is an object, the other is a primitive, but one is a set, right? And the other one is not, right? One is a bunch of letters. And it just happens that right now contains only one letter. That's not the same as saying, right? So if you had a country with only one person, right? The country wouldn't be the same as the person. I don't think even Malta has that small population, but right? A group can never, right? You have a band, right, versus a soloist, right? Even if right now everybody else left the band is a different identity from the soloist, right? Does that idea make sense? So it is the same thing here, right? One is a letter, the other one is a bunch of letters, even though it happens to be just one at a time. That is a bunch of stuff that we can do with strings. Isn't this cool? Now you know a heck of a lot of stuff about programming. Isn't this really cool? Yeah. Go read this stuff, go play with Java REPL, read the book, and get your GitLab and stuff. We still have about 5 more minutes. Check my watch. Yeah, we have 9 more minutes. So we can actually go into, I tend to do this a lot. Let me prime your brain for the stuff that we're going to start covering next week, right? Just so when you see it next week, it doesn't seem obscenely weird, right? We are going to talk about functions. What is a function? Do you remember a function in math? Do you remember graphing functions in middle school? Right? What is a function?
So a function is a computing machine actually, and I mean we give that input, and it makes some process, and it gives the output.
That's perfect. Yes, right? A function is something that I give it stuff and gives me stuff back, right? Give it a value and it returns another value, right? In Java, I can define my own functions. We'll see that you can actually make that process very, very complicated. And we'll spend a lot of time defining that stuff. But initially, right, we'll see super simple stuff because we don't know how to do complicated stuff, right? You can define a function by defining its return type. You have to say what kinds of things do you return. So this is a function. Its name is even. It returns a Boolean value. It takes one argument, int, which is an int, and inside the function, I'm going to call that thing number. And it returns whether, and I have the return keyword, right? So this is the value that's coming out. It takes that number, get its remainder modulo 2, right? And if it is 0, that means that that number is even. Does that make sense? So it will take the number, get its remainder modulo 2, and then compare that result with 0. And return either true or false. I'm using the wrong stuff. What? They just changed Java REPL. I know. Java REPL is horrible. Maybe. Yay! Java REPL expects it all to be in one line, which is absolutely hideous. In your programming, you would never do it like this, but I have to do it to show. We'll start using a real IDE and real stuff in the next week. But so once I have defined this function, I can use it. If even 3, what would this return? What does this yield? What kinds of things does it return? Booleans, right? So it's only 2 possible values, either true or false. What do you expect this to return? False. And that's what we got. Isn't that cool? Isn't this cool and magical? It allows me to start defining my own language, to take Java and start defining my own language. What we will be doing throughout this class and throughout your next 30 years is doing this stuff. You will be defining your own abstractions, you will be defining your own language, and then once you define all these things, whichever problem you're trying to solve becomes super easy. And just call these 2 functions and use their values, and that's it. Does that make sense? You will be using abstraction, this idea of defining my own abstractions throughout this last forever and throughout your career. Isn't this cool? We will talk much more about this stuff next week. Any questions? No? Then let's leave it like this. Oh, we still have